Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to insert in a Max Heap in Java. So friends, in our previous tutorial we actually discussed about what is a Max Heap, that it is a complete binary tree in which each node value is greater than or equal to values of its children. And we also discussed that the maximum value of this max binary heap is at root. And if we look into its array representation, we also discussed that how we actually place these values inside this heap array. So we simply put these values level by level from left to right. So here you can see in this heap array, if we return the value at index 1, we'll always get the maximum value of this heap. Also friends, we discussed in a previous tutorial that priority queue helps us in getting the maximum value among the collection of elements in constant time. So if we simply return the value at index 1, we get the maximum value of this max binary heap. And similarly, for the min binary heap, if we return the value at index 1, we'll get the smallest value among the collection of elements. So let's see how we can insert a value in Max Heap. So friends, in our previous tutorial, we actually discussed the basic implementation of the max priority queue. So in this tutorial, we'll actually see how we can insert a value into this max priority queue through this insert method. So in our previous tutorial, we also discussed that when we call this max priority queue and let's say we provide a capacity of 3, so it would create an integer array having length 4 because we are initializing this heap array with length as capacity plus 1, as we are not using the 0th index of this heap array, and we start inserting from index 1. Therefore here you can see the initial capacity of this heap array is 3. So here heap.length is 4. So here you can see currently there are no elements into this heap array. So the value of n is 0, which we already discussed in our previous tutorial. Also friends, in our previous tutorial, we actually saw a demonstration of how we can insert few elements in Max Heap. So friends, we will insert the same elements into this heap array and we will see the demonstration of this code step by step. So let's say first we insert a value as 4. So the insert method will be called and the value which we want to insert is 4. So x will become 4. Moving ahead. So friend, then we provide a if check that whether n is equal to heap.length minus 1 or not. So here you can see heap.length is 4 and if we do a minus 1, we get 3. So here we are simply checking that value of n is equal to 3 or not. Because if value of n is equal to 3, then we know that we have utilized all the capacity of this heap array and there is no more additional space left to insert the value 4. So here you can see currently value of n is 0 and it is not equal to heap.length minus 1, which is 3. So the condition in if block comes out to be false. In the next step, as we are inserting 4 into this heap array, first we will increment the size of this max priority queue by 1, that we are about to insert one element into this max priority queue. Also friend, as we are not utilizing the index 0, so what we'll do, we'll simply insert x at index 1. So it would look something like this. So we are simply assigning the value of x to heap at index 1 because value of n is 1. So 4 is inserted. Also friends, we discussed that whenever we insert any value in a max heap, we then perform a bottom up reheapify, which we also called as swim. So here now we'll actually call a method swim by passing in the value stored in n, which is 1. So here swim method will be called, and here you can see that as we are passing the value of n as 1, so k will become 1. So friends, then in swim method we actually provide a while loop. So what we do in this while loop, we simply check the newly inserted value with its parent, and as it is a max priority queue, we simply check that its value is lesser than or greater than to its parent, and if it is greater than its parent, then we simply swap them, and if it is lesser than its parent, then we do nothing. So this is the condition we actually provide into this while loop. So the first condition we provide is k should be greater than 1, because here you can see k value is 1, and here you can see that as there is only one element into this heap array, there is no parent to index 1 because it is the root of the heap. So the condition in while block comes out to be false. So 4 is inserted into this heap array and it is placed at its correct position. Now let's say we insert 5. So x becomes 5. We check that whether n is equal to heap.length minus 1 or not. So n is not equal to 3 because heap.length is 4 and 4 minus 1 is 3. So the condition in if block comes out to be false. Now as we are inserting 5, we'll first increment the value of n by 1. So n becomes 2. So as we have incremented n by 1, we'll simply insert 5 at index 2 by simply assigning the value of x to heap at index 2. Moving ahead. So friends, as you have inserted 5, now we'll simply perform the bottom up reheapify by calling this swim method, and inside this swim we'll simply pass the value of n. So value of k becomes 2 because n is 2. Now friends, here you can see, as we discussed in our previous tutorial, that 4 is at root and one of its left child is 5. So friends, as we have inserted 5, in while loop we'll simply check that whether value of k is greater than 1 or not. So here you can see k is greater than 1 because value of k is 2. And in our previous tutorial we also discussed that in order to calculate the parent of any index, we simply do k by 2. And why we are doing this k by 2? Because we need to compare this newly inserted value with its parent. So here you can see value of k is 2. If we do k by 2, we'll get 1, which signifies that 4 is parent to 5. And then we'll simply check that whether value at parent is less than its children or not. So friend, as it is a max priority queue, k by 2 is nothing but 1 and the value at index 1 is 4, which is parent to 5. So we'll simply compare these two values and we'll simply check that parent is less than its children or not. So here you can see 4 is less than 5, therefore it is breaking the heap order property. So the condition in while block comes out to be true. And in order to maintain this heap order property, we'll simply swap these two values. So it would look something like this. That first we will assign 5 to this temporary variable, and then we'll simply assign the value at index k by 2 to k, which is nothing but value at index 1 to value at index 2. So it would look something like this. Moving ahead, and then we'll simply assign the value of 5 to the index k by 2, which is 1. So it would look something like this. And as we have swapped these two values, now we will traverse to 5 again in order to check that whether it's at its correct position or not, because then we again compare with its parent. So in order to reach to this index again, we simply assign the value of k by 2 to k, which is nothing but traversing k to its parent by assigning k by 2 to k. So here you can see the value of k by 2 is 1, so k will become 1. And then again in while loop we'll check whether k is greater than 1 or not. So here you can see that 5 is at its correct position, because among these two values 5 is the largest value and it is placed at the top of this heap, which is nothing but at index 1. Therefore the condition in while loop comes out to be false. Now let's say we insert 2. So x becomes 2. We check whether 2 is equal to heap.length minus 1 or not. So heap.length is 4 and heap.length minus 1 becomes 3. So n is not equal to 3. So the condition in if block comes out to be false. And as we are inserting 2, we'll simply increment the value of n by 1. So n becomes 3. And to the third index of this heap array, we'll simply assign the value as 2. And then we'll simply perform the bottom up reheapify at this index, which is nothing but 3. So k becomes 3. Now k is greater than 1, which is true. Now we have to compare 2 with its parent. So we simply do k by 2. So if we do k by 2, it becomes 1, because 3 by 2 will give us 1.5, and as we are using it as integer, it will be round off to 1. So here parent is at index 1 and child is at index k, which is 3. So we'll simply compare these two values and we'll simply check that parent value is less than the child value or not. So here you can see 5 is greater than 2. Therefore the condition in this while block comes out to be false. So now let's say we insert 6. So x becomes 6. And now here you can see value of n is 3 and heap.length is 4. If we do minus 1, it becomes 3, and here you can see 3 is equal to 3. So friends, here it signifies that this heap array is filled completely and there are no more space left to insert 6. So the condition in if block comes out to be true. So what we do is, so we'll simply call resize method by passing in a value which is twice of heap.length, which is nothing but 8. So friends, in our array section we actually discussed how we can resize an array in Java. So you can watch that tutorial to understand more about this resize method. So what this method actually does is, it will resize this heap array to a size double of its current length. So once this method gets executed, it will look something like this, that heap array has now length of 8, which is double of its previous length. So we actually perform this resize method because we want to insert more elements into this heap array. So then we'll simply increment n by 1. And now we'll simply insert the value x at index 4. So it would look something like this. And then we'll simply perform bottom up reheapify at index 4. So k becomes 4. Now here in the while block, k is greater than 1, which is true. And now we have to compare this newly inserted value with its parent, that whether it is satisfying the heap order property or not. So in order to know the parent of 6, we take its index, which is at 4, and we divide it by 2. So k by 2 becomes 2. So here the value at index 2, which is 4, is actually parent to value at index 4, which is 6. So now we'll simply compare these two values and we'll check that whether value at parent is less than the value at child or not. So here you can see 4 is less than 6, therefore it is not satisfying the heap order property. So the condition in while block comes out to be true. So friends, now we know that we have to swap these two values. So we'll simply perform swap. We'll assign 6 to a temporary variable and then we'll assign the value at index k by 2 to k, which is nothing but assigning value 4 at index 4. So it would look something like this. And finally, whatever the value is stored in temp, we are simply assigning it to heap at index 2. And also friends, in our previous tutorial we discussed that whenever we insert a new value in a heap, we keep shifting it up till it reaches to its correct position. So here you can see that we have swapped 6 and 4 and 6 is at index 2. So friends, after we perform this swap, 6 is at index 2. So friends, after we perform this swap, we simply traverse to this index by assigning a value of k by 2 to k. So here you can see k by 2 is 2, and if we assign it to k, it becomes 2. And also here you can see k is 2, which is greater than 1, which means that there is a parent to 6. So we need to compare it with its parent. So here its parent is at k by 2. If we do k by 2, we get the value 1. So the value at index 1 is parent to 6. So we'll simply compare 5 with 6 and we'll check whether 5 is less than 6 or not. So here you can see 5 is less than 6. So the condition in while block comes out to be true. And as we are inside this while loop, we'll simply swap these two values using this temporary variable. So at first step, we'll simply assign the value at index 2 to temp, and then we'll assign the value at index 1 to index 2. So it becomes 5. And finally we'll assign the value stored in this temporary variable to index 1. And after we perform this swap, we'll simply traverse to its parent by assigning k by 2 to k. So k by 2 is 1. So k will become 1. Now as k is equal to 1, it is not greater than 1. So therefore we know that 6 is now at its correct position, because among these 4 values, 6 is the largest value. And we know that in Max Heap, the value at index 1 is the maximum among the other values. So the condition in while block comes out to be false. Now let's say we insert 1. So x becomes 1. So here value of n is 4 and it is not equal to heap.length minus 1, which is 7. So the condition in if block comes out to be false. Now as we are inserting 1, we'll first increment the value of n by 1. And at index 5, we'll simply assign the value which we want to insert. So it looks something like this. And then we'll simply perform the bottom up re-epify at index 5. So k becomes 5. And here k is greater than 1. So here as we have inserted 1, now we'll compare this value with its parent. So we know that this value is at index 5. So if we do k by 2 we will reach to its parent. So 5 by 2 will give us 2.5, and as we are taking it as integer, it will round off to 2. So k by 2 becomes 2. So if you see, the value at index k by 2, which is 2, is 5. So here we are simply comparing 5 with 1, because we know that 1 is child of 5. So here we are simply checking that whether value at parent is less than child or not. So 5 is greater than 1, therefore condition in while block comes out to be false. And by this we mean that 1 is at its correct position because it is child to 5, and 5 value is greater than 1, which satisfies the heap order property. Now let's say we want to insert 3. So x becomes 3. The condition in if block comes out to be false because 5 is not equal to 7. We'll increment the value of n by 1 as we are inserting 3 now. So n becomes 6. So at index 6 we'll simply insert 3. And then we'll simply perform the bottom up re-heapify at index 6. So we'll call swim method and pass the value as 6. So value of k will become 6. Now here whatever the value we inserted at index 6, we'll simply compare it with its parent, that whether it is less than its parent or not. So here k is greater than 1 because value of k is 6. So first we'll evaluate the parent of 3. So we'll take its index, we'll divide it by 2. So k by 2 becomes 3. So the value at third index is 2. So 2 is parent of 3. So we'll simply compare these two values and we'll check that whether parent value is less than child or not. So here you can see 2 is less than 3. So the condition in while block comes out to be true. So once the condition comes out to be true, in the while block we simply swap these two values. So it would look something like this. We'll assign 3 to this temporary variable. Then we simply assign the value at index 3 to value at index 6 by simply assigning the value at index k by 2 to k. So it becomes 2. And finally we simply assign the value 3 to value at index 3. So it becomes 3. So friend, as the value of k was 6 and we swapped 3 and 2, so 3 reached to its parent. So now we'll simply assign the value of k by 2 to k, because we need to again compare 3 with its parent. So once we do k by 2 to k becomes 3. And in while block we again check whether k is greater than 1 or not. So k is greater than 1 and we'll simply compare 3 with its parent. So first we'll evaluate its parent by taking its index, which is 3, dividing it by 2, which will give us 1.5, and as we are taking it as integer, it will round off to 1. So the value of heap at index k by 2 is nothing but value at index 1, because 6 is parent to 3, and we'll simply check that whether 6 is less than 3 or not. So here you can see 6 is greater than 3. So the condition in while block comes out to be false, which means that 6 is at its correct position and also the 3 which is at its correct position. So friends, here we saw the demonstration of how to insert a value in a max heap, and we saw the demonstration step by step. We also saw that how we can perform bottom up re-heapify in case the heap order property is not being satisfied by inserting a new element. So friends, in our next tutorial we'll code this insert method and we'll test its working. I hope you like this video. Thanks, have a nice day.